So, Chapter 7, how to handle exceptions and validation, or validate data. As you code out in the real world, this will be something you have to do all the time. As you've probably seen here already, as you're writing your code, and let me share this on Discord real quick before Liam asks me to. So this is something you'll have to do all the time as you're writing code, is make sure you handle exceptions and validate data. As we've been coding along so far in all these labs, you probably see quite a bit of times your program crashing where you get unaccepted error handling part where that little window pops up. You can select details, continue, or quit. That is an exception, and that causes your program to crash. Hopefully with Chapter 7, we'll learn how to handle those through system exceptions and user-defined exceptions to handle this kind of stuff. So our program won't technically crash, but something will have to be done to keep it working. Objectives part 1, given a form that uses text boxes to accept data from the user, write code that catches any exceptions that might occur. Given a form that uses text boxes to accept data and the validation specifications for that data, write code that validates the user's entries. Some of you have already been writing some kind of validation code when you check for something being empty strings or blanks or a null here and there. So as you code, you're going to be having to write code like that a lot just to handle anything that may come up. These exceptions that we're going to be writing will catch a lot of things that can come up we don't expect to, but just in case they do, we'll be able to handle them and keep our project from crashing. And then use dialog boxes as needed within your applications. Let me show you like this part because we start using the Windows, the dialog box that pops up, and you can say OK to it and that. I know you like putting those in your code. Explain what an exception is and what it means for an exception to be thrown and handled. Describe the exception hierarchy and name 2 of its subclasses. Describe the use of try-catch statements to catch specific exceptions as well as all exceptions. Describe the use of the properties and methods of an exception object. Describe the use of throw statements. Describe the 3 types of data validation that you're most likely to perform as on a user entry. Describe 2 ways that you can use generic validation methods and a method that validates all of the user entries in a form. So as we go through these slides, we won't go through them all just because a lot of them towards the end start talking about the project that the book's writing. So I'll cover some of this, and then I'll show you a couple examples in code on how it actually works and how to do it. So as you can see here in the dialog box, they have an unhandled exception. Usually gives you that red X there, tells you system format exception, input string was not in correct format. A lot of you probably been running into this already. And then the exception hierarchy, the 5 common exceptions. So when we throw exceptions, we have what we call system exceptions. The system exceptions is no different than that system's objects that we've been using, like the toStrings and some of those methods and objects. This handles a lot of the exceptions for us. There's probably hundreds of them that are out here coded. The most common ones is the hierarchy of it, is the big dog of them all is this exception class here. This will handle everything if need be. And then you have a format exception that handles formats to where if they're putting the wrong data types in, it will catch that and let you know that it's the wrong data type. Then you have the arithmetic exceptions. A lot of that's if your math is wrong one way or another. Most often there you'll have a divide by 0 exception. So if you're trying to go in and code, we can't divide by 0, it'll throw an error. So you can see here like this on this C# exception hierarchy, they have object, which is top of everything. Then below that's the exception, system exception, application exception. Application exception, we won't mess with any of that. More than likely, most of the time an application exception is like if Visual Studio would happen to crash or something go wrong with that. There's nothing we can do about that. That's something to do with the software itself, not what the code we're writing. System exception, you have external exceptions, some COM exceptions. We don't usually mess with that very often. More often than not, you'll see like these null reference exceptions, invalid operation exception, an argument exception, a null exception. A lot of times with Java, it was like a null pointer exception. We had a lot of that. But hopefully these try-catch blocks will get us to where we don't have to worry about it. So as an example here, W3 Schools, they do a pretty good job of explaining stuff. So you start with the try, you have your curly brackets. Inside the try is the code you want it to try to see if it's going to come up with an error or not. And then you do a catch. You have the exception class. That little E there just means that's a variable for the exception. On this one here, they're doing an integer or an array, I'm sorry, and their values are 1, 2, and 3. So we have two sub-indexes, 0, 1, and 2. It goes up to here. They're saying show us number 10 because there is no number 10. You'll get system.index out of range exception. That's one of the system supplied ones that you see. I think we've seen that quite a bit working with arrays and some of this stuff. And so index was out of the bounds of the array. Again, here's another one, same thing. You can also create your own message. Something went wrong, and I'll kind of show you that. And then last but not least, they have a finally block to this. So if you run something and it catches an exception, it will throw your exception, tell you what's wrong with it, and then you have this finally code that runs no matter what. Once you catch that exception and throw it, this finally code will keep running. So a lot of times, I think one of them they do, I think it's in our slides, I'll show you in a minute. They have a function at the end that does clean up on it. So here they're doing age check. If age is less than 18, they're passing in the value of 15 for the age check down here at the bottom. It's 15 is less than 18, throws access denied. The way they have it written out, they put their own message in it. And then console.writeLine, access granted. You're old enough if you're old enough. So I'll get more into this as I start doing some code demos for you. Where did my slides go? So some of the exceptions that might get thrown. So like if you're trying to convert something to a decimal, you can get a format exception from a string, overflow exception. The overflow exception on your number parts, I guess you'd call it, the decimals, the integers, is if you have a value greater than what the data type actually holds, then you'll get that overflow exception. So you'll see that occasionally if you're trying to put too big of a number in for a decimal or for an int or something like that. Parse a string for the decimal, you get this overflow exception and format exception. Same with date time, you're putting it in wrong, it will come up as a format exception. There are ways to handle it using the converts properly. Using the parse, we can parse it to make sure it's that type of data we want as it goes in and checks it. If it does, it passes and it does it right. If not, you have to catch it, throw an error and letting it know it's not right. So a lot of times when you throw these error messages, you can show a message box. So we'll do a message box.show. Jamisha's good at those. But you put your text in. The caption is just the heading up top. And then you can tell them what they actually did. You can display your message out in this message box and tell them what they did wrong. They click on OK button. The code will keep working, and they have to go in and fix what you tell them they did wrong. So, like I said, I'll show you a demo of that here coming up as we get a little bit further into these slides. Syntax for a simple try-catch statement is you always start out with the try. So you have your try here. Anything you want to test to make sure it's not going to crash your program, you put inside the squiggly brackets here. Right after the squigglies, you put your catch. Catch is going to catch any kind of error that comes out of here. And we either throw an exception down here to let them know what happened, or you can do a message.show and tell them what happened, what they need to go in and fix. This way it keeps, so like I said, the program from crashing. It won't blow up, won't have issues. Nothing worse than when you're out on a website or filling out a big form and go submit it and it breaks because of some kind of data issue that they didn't handle, and you have to go back through and restart it all. It just becomes a total pain. Get very frustrated. It makes you not want to go back and use the website or anything. So syntax for try catch that accesses the exception. So the stack trace down here, the message gets a message that can display out to the screen, tell the user what they did wrong. The stack trace runs through all the methods that were called, that were used before you hit this exception, and then lets you go back and look back through where it actually happened so you can go find it. The message you'll put out to the user a lot of the times so they know what they did wrong and can go fix it. The stack trace is used more for development, so as you're coding through this and testing it, you can put stack traces in your code. That way if something blows up or breaks, you can go out to the console and look, dig through, and see exactly what method it broke on and go back and fix that method so you can get it cleared up. And same thing with this get type. This get type gets the type of the current exception. You don't see that as much as you do the stack trace actually being used. I think they give an example. Yeah, they do a convert decimal, and they catch it with the message box. In the message box, they're showing this get type to string, and then the stack trace exception. So you can see here, the exception input string was not in the correct format. System.format exception, and it kind of tells you number and buffer, numbers, all that stuff. At system parts, state string, all that, and then what it was in, what line 24. So like I said, that stack trace you'll see more often than not as you're developing it yourself, just to get the errors to kind of print out to the console instead of with a message. Try catch for a specific type of exception. So as you do these try catches, you can do more than one try catch in a block. You can do a try and then a catch and a catch and a catch. But as you do them, you want the most specific exception first. A lot of times that's like a format exception or something like that as they're putting data in. And then you can kind of narrow it down further and further. The most one should be up top. Like I said, can't think of the word now. I just said it. Let me think of my word now. Oh yeah, the format exception. The format exception, usually most specific. A lot of the system ones are going to be most specific. And then as you go down, you'll catch it with the next most specific and then the least specific. So that way you can catch anything that happens to fall through. If the first one doesn't catch it, the second one may, the third one. And then again, that finally statement at the end. So here they do a try catch, and they have a couple different ones that they're doing. So you can see a try, catching a format exception, then an overflow exception next, and then just this exception EX to catch anything else that may happen to fall through that the format exception and the overflow exception don't catch. Syntax for throwing a new exception, just like an object, instead of Declaring a variable with it, and that we just do a throw new, whatever our exception class is, whether it be the system or our own, and then the message that goes in the message box so the user can see what went wrong. Throwing an existing exception, you just do throw the exception name. When to throw an exception: when a method encounters a situation where it isn't able to complete a task, when you want to generate an exception to test an exception handler, and when you want to catch an exception, perform some processing, and then throw a new exception again. When you're trying to catch these exceptions, if it's something that seems to be happening over and over and over again, that's not when you want to catch the exception or throw an exception. You want to use it in a rare case to where if you're not expecting something to happen. If something keeps happening over and over and over again, there's more than likely something more wrong with your code that you need to go in and fix rather than letting this exception handle it all the time. So you want to try and keep them limited to catching these errors, but make it something that is kind of unexpected, or you're not expecting something that the user could unexpectedly do to cause an issue to come up in this. So let me see if there's any good examples. I think we're getting close to the end. So here, one of the last things before I start kind of going over some code and showing you how all this stuff works is, again, like we said in the past, when we do declare a variable, the data type, and we put this question mark here, that question mark saying we do allow a null value at that point. It's don't throw an error, we allow it. When we get down here with this product code, we say, yeah, you can take a null value. It gives it a null value here. Well, then when we do the string code, we have this product code and these double question marks here. These double question marks are called null coalescing operators. You don't see them used much, but it's something kind of newer in C#. And since I've never really developed in C#, it is definitely new to me. But what it's saying is, it's almost like an if statement saying, if product code is not null, go ahead and assign the product code to our string code there. But if it is null, throw this new exception saying code cannot be null. So it's almost just like an if statement saying, if product code is not null, assign it to the value of code. If it is null, assign this error exception to code and throw the error for us saying code cannot be null. So if you want to use that, you're more than welcome to. Like I said, I haven't coded with it yet really to be familiar with it, so I may have to play around with it a little bit more to get comfortable with it. But with that being said, let me bring up my Visual Studio Code, and I'll code out some demos of this just so you can see it. But some of the more common exceptions you'll get, there's two types usually. There's a system exception and a user-defined exception. We're going to be working with both. We're going to be creating our own exceptions here. And then some of the more common system exceptions you'll get will be like a null reference exception. When you're working with objects, you'll have a tendency to get that a lot. The one job I worked with, that was like the first thing you did was always check for a null reference exception to see if your object was going to be null and have a chance to crash your program, because the null exceptions will nulls will crash your program a lot of time. Index out of range exception, divide by zero exception, arithmetic exception, such as that divide by zero or the overflow. Format exception occurs when converting a string to a numeric type or other data type. Out of memory exception occurs when there's insufficient memory to perform an operation. You don't see that as much nowadays, but back in the beginning days of computing, you used to see that quite a bit, that it was out of memory exception. And then a timeout exception, operation time takes too long, longer than expected, crash your program. So let me get my Visual Studio Code fired up here and create a new project. I was messing around with it with this .NET framework last night. I wasn't having any issues with it, so I'll give that a shot again today, since we've been kind of using that for the most part. You know what? I think we still use some interfaces interfaces coming up in this next couple labs. So let me go back to just a Windows Form app again. So if you want to just start using Windows Form apps instead of the .NET version the rest of the time out, you're more than welcome to. So I'll call this exception handling example. Put in my examples.
Which chapter is this?
Chapter 7. So I got this up. I'm going to go ahead and just throw a button on here real quick. Call it generate exception. Generate exception. And so what I'll do in here now real quick is just I'm going to throw. Actually, let me create a class real quick. And I'll call it a negative balance exception. We'll change the class to public, and we will be writing exceptions like this. So, and we'll do public negative balance exception.
Did you put any labels on that?
No,
Okay.
I'm not going to print anything out at the moment. I'm just going to throw exceptions. So in our constructor for our negative balance exception, we pass in a string and a message, and then we use our base and a message for the base. And with the bless you, in the base we can do colon exception, CEPTILN. And you can use different exceptions if you want up there. Most of the time, being exception is the top dog of the exception classes, we just use exception.
You made a class? Sorry, I'm trying to catch up.
Yep, create a class called negative balance exception.
Where did you go with that?
So if I go back to my form, I can do a throw new negative balance exception, and we're going to pass in here, oops, balance cannot be negative. So now when I try and run this, got my window. When I click on this, you can see there's an unhandled exception. This is what we keep seeing as we're coding our stuff out. It breaks. You can see our little message here that we put in. It says balance cannot be negative down here just above the buttons. So our throw new negative exception or new negative balance exception, that's what it threw there. That's why it showed our text balance cannot be negative on that window. There it is there, balance cannot be negative. You have an unhandled exception occurred. So that's what it means when your computer or your program crashes. This gives us a little notification as we code it to tell us that something's wrong, fix it before you actually publish it out as live software. So if I click on it again, I can go to details, and I've shown some of you this. If you go to details, scroll down just a little bit over to the right, it tells you what line caused your issue. Exception handling example, line 12. There's our line 12. And there's throwing our exception there. So now to handle this stuff so it doesn't break like that, we do a try catch block around it. So we'll do a try curly bracket, and then we do a catch. And in that catch, we're going to do a negative balance exception in there. Negative balance exception in there. And then we give it the variable EX. Because this negative balance exception is a class that we created, that negative balance exception class. And we're passing in that EX as a variable. After the catch, you got to put your curly brackets in again. And we're going to do a message box in there. Dot show. And we'll do, and you can see our EX isn't happy here. It's saying it's not being used. We're going to use it now. Dot message. And we can put a comma there and say error message and our semicolon. So now if we run this, make sure my thing's closed, we'll go ahead and run it. Get our window up, click on it this time. This time, instead of our program crashing, we handle that error, we handle that exception, and we say, show us balance cannot be negative. Click OK, and our program would continue running if it need be. The user would have to go figure out what they need to fix. Yeah.
What's going on with the brackets on try?
So after your try, you have a curly bracket. You put your throw, your exception in there, and then you close your curly bracket. And then once you close that curly bracket for the try block, you put your catch block in.
Did you put anything in the class? Like in the class too?
No, our class just calls the exception itself. We set it up saying,
I'll have that. So see that real quick, please. I have to write it down.
so we call our negative balance exception class, we give it the variable EX. We use that to call our message. Our message is balance cannot be negative. So when we actually run this again, there's our title error message, balance cannot be negative. So it goes and lets the user know they need to fix it. And so that's the nice thing about this try catch block. If we didn't have that, again, it would crash our whole entire program. And cause issues. But because we're handling it, it does not let our program crash. And they can go in and change whatever data they need to change to keep it working properly. balance cannot be negative. So to expand on this a little bit more, now we can create our own classes. We can throw our messages and our errors, and this will be more of a bank one to kind of show you guys how to do this, because you're going to need to do it for one of your labs coming up. Yeah, Liam.
Just 1 second. I didn't finish writing down what was on the class.
Okay, and the class itself?
Yeah, right there.
The class or the form?
That right there.
The class. Well, if you want, we'll go back in, create another class. Call this one account. Like I said, this will kind of be the way you're going to be doing your banking one coming up. Create a class called account, make it public. Put some data in here. We're going to do a public int ID, get set, public string name, get set, do a public double balance. We want to manipulate this balance a little bit with some code, so we're going to put a instance field up here called balance double underscore balance. Make a little note here. That's our instance field there. These are our properties. Get sets. What's the other name for them? Anybody remember?
Getters and setters.
No, there's
Not that.
yeah, there's another name that we use for them. Accessors and mutators. The gets are the accessors, the sets are the mutators. So in our balance here, we're going to do a little code in here. So we're going to do a get and we're going to do something with our set. Kind of ugly way to do it, but it gets it done. So in our get, of course, all we want to do is return our instance field value for balance. And in our set, we're going to do an if statement in here to check the value. If value is less than 0, we don't allow them to have a negative balance, so we're checking there for a negative balance. And let's set our balance here to 0. And in here we can throw a negative balance exception from the class. Oops. And say negative balances not allowed. So we're just saying here, we go set the balance. If it's less than 0, throw a new negative balance exception. So then we can go back to the form. And we can do a try. Try. And here we're going to create an account object. So we'll say account A1 equals new account. And we're going to assign it some values and say balance equals negative 1200. That looks more like my bank account. Name equals Doug. Since it's close to my bank account, I'll go ahead and use my name. And ID equals 1. So we're going to try that. We know it's going to throw an error because our balance is negative 1200 and we said we're not allowing a negative balance. So let's put our catch on here. Catch is going to be a negative balance exception. Give it the variable EX. And we're going to put a message box again. Let's show EX.message. And we're going to add on to this. So put a plus sign for concatenation. We'll say balance cannot be negative. If we wanted to, we could put a finally block down here. We're not using them at the moment, so that would be how you do a finally. Something like that. If you want to use a finally on it. So now if we run this, we expect when our catch throws our exceptions for us, or when our exception throws up here and the catch gets it and displays it, should say line 23 maybe. I don't think it's going to though, because we didn't just throw the exception. So let's run it. Generate exception. So you can see we caught the exception. We're displaying our message box. Negative balance is not allowed. That comes from our class. And then we added on that balance cannot be negative in our actual form here. So this negative balance exception, it goes back to the class account. When we hit this if statement, get our negative balance, it throws this exception out of here. Our negative balance exception class gets that message, and then it comes out to our form in this ex.message here. The ex is our variable again for our negative balance exception, and then it just puts the message to it. So that's where that message comes from, is our account class we created, showing that we had a negative balance. It throws that exception. If we didn't have that catch in that, our program would break because of that negative balance. Go to our form. We run the code. This balance here causes it to break from our account class. There's our balance. Our if statement in our setting that value. Throws our negative balance exception into our form. handles it, keeps our program from crashing. I think once we click that, it should show we are finished after that. Yeah, we are finished. So if you have an exception, you handle it, catch it, and this finally block will run whatever. Sometimes you may reset all your fields back to blank. You probably will set focus to, or set a highlight around the text box that caused the issue as they're putting values in or something like that, just so they can see what's going on with it. So any questions or comments, concerns about this? The account class? Negative balance class?
Don't get off of the-
Would we rather use like a try to catch an exception rather than like having an if-then statement and displaying it in like a text box or a label?
Yeah, because even if you display it in a label without that try-catch, it's still going to break. That try-catch prevents it from breaking. If you'd rather show your error in a label instead of a message box, you know, you could put like your label, invalid text, or something like that in there, and you're going to end up doing that in your labs, is using a label to display some error messages, kind of like when the grocery store, when we had the invalid key and it showed that little message, invalid key. You could put a try catch around that to make sure the keys matched and didn't break it, and then you could throw that notice up, change the label to the color red and say invalid key, access key in there. Any other questions? If not, I'll go ahead and stop the recording here. You guys are welcome to take a break,
I got one question.
and then we'll start labs after that.
I got one question.
Yep.
On the account class,
On which one? The account class?
Yeah.
Yep.
the name is not.
Not-
When I try to press exception, the button, I'm getting something completely different than you know,
Let's take a look.
you put a question mark there?